We'll proceed in parameterization in calculus Jacobian 3D. Jacobian 3D. Jacobian 3D for 4 dimensions. Jacobian 2D for 3 dimensions. Jacobian Jacobian 2D Jacobian 2D for Jacobian 2D for 3 dimensions. Jacobian 3D for 4 dimensions. So that is the concept why it is important. Jacobian, like we say in machine learning artificial intelligence, the coordinate system will have orthogonal components that will be in hundreds and thousands. Someone would go dimension reductionability to reduce the number of components and turning the collinearity as low as possible. Collinearity in machine learning is nothing but each feature, if I have 10 features against each sample, all 10 features should behave as orthogonal to each other. Orthogonal to each other means like if I have x-axis and if I have y-axis. One is independent, one is dependent. Y equal to function over x. Y equal to function over x. If I keep changing x, y would change as per the graph would change. Y is dependent upon x. If I have xy plane, x-axis, y-axis, x-axis, y-axis. If that is the case, then I have vertical as z-axis, that is function over x and y. X-axis, y-axis, both are independent to each other. So, if I have xy plane, on top of it, there is a surface. If I have x-axis, if I have y-axis, this is xy plane, there is a surface over xy plane. This surface is constructed by function over x and y. So if I take any point on xy plane at x comma y, if I take any point on xy plane at x comma y, then if I pass this s comma y to Python function which takes the x comma y, does some computation and returns one numerical value, that is fxy. That is the vertical numerical value. If I connect all these vertical points, it constitutes a surface. Now on the surface, consider I take any point and its coordinate is x comma y comma z. Now that point is P, then what is the position vector? Xi plus yj plus zk. Now what is dp by dx? What is position vector by dx? dp by dy. If I have a surface like this is xy plane, I have a surface like this, and I take any point here, P, from origin there is a position vector like this. Now, this is the position vector. What is the position vector? Position vector has magnitude and a direction. So what is the magnitude of position vector? X square plus y square plus z square square root. X square plus y square fxy whole square square root. What is the direction of this for this position vector? Xi plus yj plus zk divided by square root of x square plus y square plus z square unit vector. Very nice. Now I am shifting x. Instead of x comma y comma z, there is a new point called x plus delta x comma y plus zk. Only x. There is a position vector p, that is xi plus yj plus zk. There is another position vector p, p2 as x plus delta xi plus yj plus z plus zk, because I change only x. Is it correct? Xi plus yj plus zk, and if I moved little bit in x direction, x plus delta x. I did not change y and z. X plus delta xi plus yj plus zk. Y is unmoved. Is it true? True. Because x and y are independent to each other. Z is unmoved. Not true. Because z is dependent upon x and y with function fxy. So the new term will be x plus delta xi plus yj plus z plus delta zk. Z moved because z is not independent. Z is not independent. It is dependent upon x and y. If any of them changes, z would change. This is independency and dependency. So Jacobian, if someone is why we need Jacobian, we have demonstrated very clearly. Now, if I have xy plane and on top of it I have fxy, that is z, if I connect all the z points, it constitutes a surface. Instead of xy plane, I have xyz xyz coordinate system. I mean, xy plane is independent. X-axis and y-axis, they are independent components. Z is dependent upon them. Now, there is a new terminology where three axes are independent. X, Y, Z. All three are independent to each other. If that is the case, then instead of xy plane, there is a xyz cube, cube. It can be rectanguloid also. Consider cubical, cube. If xy plane, if I have a function over xy plane, and that function transforms into z, then what about this xyz cube where it is independent cube, then it would transform into what? fxyz, function over x comma y comma z. I believe I have already taken example for it. Okay, so this is a cube, this is a cube, and this is a xyz. X from my side, x axis, and then y axis and z axis. So my side x axis and then y axis, and then from here z axis. It is a cube. If you see it, then it is a cube. If it is a cube, it is a cube. This is nice. It is a cube. All three x, y, z are independent to each other. If that is the case, then this is a x, y, z cubical. What about fxyz? Fxyz is a function over xyz. Where it would go? X-axis, y-axis, z-axis, all three axes I consumed. Then where the fourth axis would go? It is called density function. The density of this box is not same. Somewhere it is high density, somewhere it is less density. So this is typically called four dimension as density function. Density fxyz equal is density function. Now I can take any point inside this box x comma y comma z. This is xy plane. This is xz plane. This is yz plane. Okay, but all three are independent to each other. Okay, what is dependent? Density is dependent upon x, y, z. Is it really true? Density is different? Yes, it's true. Actually, it is a speaker box. Actually, it is a speaker box, and there are wires, and then there is a plastic, and inside the plastic there is a speaker. Oops, you can see physically this is a speaker. Okay, so inside this there is a a speaker. Now, certainly every point density is different, right? Inside a speaker there is electronic circuit, and then in electronic circuit then there is a semiconductor, means silicon, and then plastic, and then real speaker, and then cable. Inside that metal is there. So inside this box, everywhere density is different, and that density where at what point, what is the density, that is as per the algebra. So algebra is fxyz is the density function. Now, so each point xyz would map to a density. If I say, well, my xyz is 0 comma 0 comma 0, okay, then density is something. Open it and find what is density out there. Is it air? Okay, my coordinate is 4 comma 3 comma 4. So x-axis 4, y-axis 3, and z-axis 4. What is then? Open and see at that point what is the material. That is the density function. That is the density. So fxyz is density function. So at every moment it talks about density. So if I map any point xyz, it would map to a density, because at that point there is a density. So if I keep mapping all the xyz point, it will keep mapping to a density. If I connect all this density, then it will make a density volume. So xyz cube would map it to density volume. If it is volume, can you show me what is the volume? Volume depends upon the density everywhere. And if you take the amount of the density, it will make a volume. You can draw it. Okay, show me. I'll show you. Okay. So this is density. Okay, so this is the cubical coordinate xyz coordinate system, where x, y, and z are independent to each other, and at each xyz I mapped and it became a density. If I connected all the density point, it became a volume like this. So this xyz axis mapped into density volume. Okay, it is oriented like this, whatever it is. Now now if I take any point, in the density, what is that point? X comma y comma z comma d. X is what is the independent component x is, y is what is the independent component y is, z is what is the independent component z is, comma what at this x y z, what is the density. So in four dimension, if you take any point, it has four coordinates, x, y, z, and the fourth dependent one, that is the density. Someone can say, is it x comma y comma z comma fxyz? Yes, this is x comma y comma z comma fxyz. So for simplicity, I took out the density volume like this. And if I take any point P here, what is the position vector? Fourth component density is imaginary. It is not z-axis or y-axis. Density is like in 3 xyz component, if I take x-axis only, then density is something, how much dense it is along the x region. There is no z. If I see how much is this value, then it is z value. How much is this value, it is y value. How much I go along x value. Okay, I am concerned about x and density. Every moment, just think that this is not a wooden, think that it is made of something that has different density at different point. This side it may be very light, at the center it may be very heavy, here again little bit light, different density. If that is the case, then this is x axis I am moving, at each x density is different. It lines up into a different plane called x density plane. If it is y-axis, then it is, I can land up in a different plane called y density plane. If this is z-axis and everywhere density is different, I land up in a different plane called Z density plane. Now, if this is density volume mapped from this XYZ cubical region, then if I take any point P, the position vector is xi plus yj plus zk plus d gamma. This is what I said. Consider the fourth coordinate is gamma. Then d gamma, where d is fxyz, function over xyz. I understood what you are saying. Now, what is dp by dx? If I move along x-axis, then how much position vector is changing dp by dx? Boss, this is very difficult. I really don't know. Or let's take simple example. Oops, thank you. So, I have one circle. I'm talking about the most simple 2D or 1D Jacobian. Now, this is Now, this is x-axis and this is y-axis, and the circle is centered at x is centered at the origin. This is circle centered at the origin. Now, if I take on this circle, if I take any point P, then what is the position vector of this P? This is center P xi plus yj, where y is dependent upon x, y equal to fx. This is x-axis. If I take any point P here, here it falls, this much is the x. If I go little bit delta x, I change x little bit, then this position vector from here, it would shift to here. Because x little bit, I went right side. Earlier the point xi plus yj is this point, then next point, see, since this is the x, since this is x-axis and we are talking at point here, that correspond to point here, that is xi plus yj. Now, if I take go little bit right side, then it is x plus delta x. Corresponding point here is x plus delta x, comma y. But y will not be same as this y because y is changing because y is dependent upon x. So this point is P. Then this is a new point called P2. How much position vector is changing if there is a delta x change in x? dp by dx. If there is a 1 unit change along x-axis, how much position vector change is seen? dy by dx. How much vertical component is changing if I make unit change in horizontal side? How much position vector is changing? So earlier, if this is the x-axis, then position vector was like this. Oops. If this is x-axis, if this is x-axis, if this is position vector, if I move along x-axis, position vector also changes. Okay. How much change in position vector from here to here? It changed because x-axis changed. How much change in position vector is seen? dp by dx. What is the earlier position vector? Tell me the magnitude of the earlier position vector. X square plus y square square root. What is the magnitude of next position vector? X plus delta x whole square plus f function f x plus delta x whole square root. It will not be same y, or you can say y2 x plus delta x whole square plus y2, where yt is nothing but function over x plus delta x square root. Okay, what is the change? It is the magnitude of the position vector change dp by dx. What about its direction? Earlier the direction was xi plus yj divided by square root of x square plus y square. What is the new direction? X plus delta xi plus fx plus delta xj divided by x plus delta x whole square plus fx plus delta x whole square root. This is dp by dx. Now let's go back to the density area. Now I have in density area, okay, so this is the density volume. If I take any point in the density volume P, then its position vector is xi plus yj plus zk d gamma. This is position vector. What is dp by dx? dp by dx is I plus d density by dx gamma. Can you see j and k component gone? Because they are independent to x and y. If they are independent to x and y, if you change in along x-axis, y and z are unchanged. They won't change. But dependent component density would change. I'm not talking about d density by dx, dp by dx. If I take circle, if I take circle and at any point x, at any point, at any point, at any point, okay, at any if I take like this, at any point x, this is the point where height is y, x comma y. What is dy by dx? If you make unit change in x-axis, then y, this point would change from here to here. How much is the y change? Dy by dx. How much is the position vector change? If this was the position vector change. How much position vector change? dp by dx. How much y change, height change? dy by dx. Both are different. One is vector. Similarly, if I have, if I have, oops, similarly, if I have a volume, if I have a xyz volume, cubic cube, and this cube as per the fxyz, it mapped into density and it resulted in like this. If I take any point on the density, then it is p xi plus yj plus zk d gamma. What is dp by dx? What is dp by dy? What is dp by dz? dp by dx is change in the p. If I move one unit along x-axis, then how much p would change? That is I plus d density by d density by dx gamma. So if you see now, if there is a vector called I and gamma, then this vector lies in x and density plane. X density plane. X is one axis, density is another axis. X x density plane. dp by dy, j plus d density by dy gamma. dp by dz, k plus d density by dz gamma. You see, one is changing in x density plane, one vector is in x density plane, another vector is in y density plane, and third is in z and density is separate axis, z density plane. Three planes are coming into the picture. What is now? Consider dp by dx is a vector, right? Consider it is vector name is a. It is in a density plane. This is x-axis. What is this vector? I. This is x density plane. Where is plane? It is an axis. Density axis is imaginary because everywhere density is different. Looking at the density, consider this is height. Even though height is z-axis, consider here density is less, so height is less. Here density is high, height is high. Here density is little less, so this is x density plane. Now it is simple. So in x density plane, this is xd vector, that is dp by dx. This is y density plane, then that is dp by dy. If this is z, then consider this somewhere, this is z density plane. Okay. Now the x density plane, the vector is I plus d by dx gamma. Consider this vector is a. dp by dy is a vector j plus dd by dy gamma. Consider that vector is b. If I say I'm going to calculate cross product of a and b anywhere, if I don't bother in what plane they live, if this is x, if this is a vector and this is b vector, they make another plane. This is lying in one plane, this is lying in another plane. I don't bother. If I have a vector a and if I have a vector b, they make another plane, ab plane. In that plane, if I do cross product, then they give me the area in between it. Doesn't matter. They make separate plane. What is that plane? So A cross B is the area. It is also called density area, but it is not density area because there is a division by x and y. It is called velocity density area. Velocity, this is nothing. This is whole dimension I am talking about. In artificial intelligence, someone has to imagine 100 dimensions. I'm just making people imagine the 4 dimensions. Someone has to imagine 100 dimensions. Here, here, if you have any problem in imagining, you can watch our video, Architecture of Human Brain. Okay, there is series of video called Architecture of Human Brain. So how human brain works, that you have to understand. Probably that would help you. So anyway, now we are talking about density, area, velocity, plane. Now if I take simple cubicle, now now we talked about density, area, velocity, vector. So if this is the density volume, then this is x is in x density plane. This is oh, this is this is in y density plane. If I do cross product, it would give me the a cross b, that is dp by dx cross dp by dy. For simplicity, not in the density volume, in simple xyz volume, if this is the volume, if this is x-axis, this is x-axis, this is x-axis and this is y-axis. If I calculate cross product, it will give me xy plane area. And after, but but its direction will be along the z-axis. Now along z-axis I have, if this is a cross, this is x cross y. If I do again a cross along z-axis, it will result in 0. I'm trying to calculate volume. If that is the case, then x cross y dot product with z would give you the volume, but it will not be a vector. This is called scalar triple product. Okay, so x cross y dot with z. Similarly, if I have dp by dx, dp by dy, whatever I have, now I'll do dot with dp by dz. It will give me density volume velocity vector. Density volume velocity. This is anyway a volume. Can I calculate volume? Something like this? Yes, you can calculate. If xyz transforms into a density, if it transform into a density volume, then can I calculate density volume like this? Yes, dp by dx cross dp by dy dot dp by dz. Since it is a velocity volume, then you have to now integrate, get the magnitude of this and integrate it with dx dy dz, because you have to get rid of the denominator dx dy dz. Integrate with dx dy z, you will calculate the volume. Take it as an assignment. And support us. +91 is India country code 94831 60610. 94831 60610. Okay, so this is how it is. Now we are in process of calculating Jacobian. So now what we knowingly, unknowingly, what we calculated, if I have fxyz, if I have xyz independent coordinate, then if I have fxyz, this is fxyz volume, density volume. Then if I do dp, if I take any position vector here, dp by dx cross dp by dy dot dp by dz, then knowingly, unknowingly, density volume by dxyz or d of fxyz, if density is dependent upon xyz, then it is something like dp, that is the point on the density, dp by dxyz plane, dp by dxyz plane, where p position vector is dependent upon xyz. Now, if I'm trying to calculate volume, if I'm trying to calculate weight, if I have a density function, if you integrate density function along xyz volume coordinate, it will give you the net weight, because density is anyway kilogram kg per meter cube. If you integrate with meter cube multiplication, it will give you the weight. Like I have an example where x is where where z is 0 to 3, y is 0 to 4, and x is y by 2 to y by 2 plus 1. Famous example. Z is 0 to 3, y is 0 to 4, x is y by 2 to y by 2 plus 1, and integrand is x plus z by 3 dx dy dz. I cannot integrate y by 2 to y by 2 plus 1. Can you make it simple? Okay, then I have density that is dependent upon xyz. Now bring another UVW volume. So this XYZ coordinate system is mapped into a 3D density volume. What is the shape of this 3D? I don't know. What is the shape of the in XYD? In XYZ, I take a cube, pure cube, very nice cube. But when I applied fxyz function over it, it transformed into like this. Okay, this is not apple. Consider some 3D. Okay, if that is the case, now if I cannot do the integration, I will not take another cube region for the help, that is UVW, cubical coordinate system. Cubical coordinate system, UVW, not UV plane, UVW cubical coordinate system. Now if I take this cube in UVW, then this cube would transform into some cube would transform into some volume in xyz. If there is a cube, then it will transform into not into cylinder. Consider something in xyz. Okay. Now, if I had taken cube in xyz, then it would transform into like this in density volume. Now, there are three things coming into the picture. This is parameterization. So if I'm not able to calculate the integration where z is 0 to 3, y is 0 to 4, x is y by 2 to y by 2 plus 1, and then x plus z by 3 dx dy dz, I'll take help of another coordinate system UVW, where x is equal to function over UVW, y is function over UVW, z is function over UVW. Similar way, density is function over xyz. Okay, if that is the case, then xyz is no more independent. They are dependent upon UVW. Same fashion. Okay. Now, if I proceed now, then limit what we have. If I take u, then what if I have function x equal to UVW, g UVW, y equal to h UVW, g h are function like f, and z equal to t UVW. If that is the case, then if I change the limit, I have to change like this. Limit was in xyz, it will be in UVW. The integrand will be in UVW. What about dx dy dz? That is dxyz volume. That is same as dxyz, d small d bracket open, x comma y comma z bracket close, dxyz by duvw into duvw. dxyz is same as dxyz by duvw into duvw. duvw numerator is du, dv, dw, whereas its full term comes as Jacobian, dxyz by duvw. Earlier, d position vector by dxyz was dp by dx cross dp by dy dot dp by dz. Now, if I have dxyz by duvw, if I take xyz as a position vector p, then again dp by du cross dp by dv dot dp by dw. Same thing. Okay. So it depends upon dp by dp by du cross dp by dv dot dp by dw, where p is xi plus yj plus zk, because we are talking about two coordinate system. Earlier we are talking okay, earlier we are talking about xyz, xyz and density. Okay, then on density we took a position vector. Now we are talking about uvw and xyz. Now here on xyz I took a position vector. Here on, so if I take a position vector p and we are talking about dp by duvw, then it will be dp by du cross dp by dv dot dp by dw. Now any position too many things on my, I can keep it here. So if I take, if I, if this is uvw volume, if this is xyz volume, if I take any point in xyz volume, that is xi plus yj plus zk, so dp by du, okay, uvw and xyz, dp by dp dxyz by duvw into duvw is same as dxyz. We are transforming dxyz to duvw, that is nothing but dxyz by duvw into du dv dw. This is Jacobian, dxyz by duvw, that is dp by du cross dp by dv bracket close dot du dp by du. What is p? Xi plus yj plus zk. Xi plus yj plus zk by du is dx by du, dy by dx by dui plus dy by duj plus dz by duk. Okay, cross product with dx by dy by dui, dy by d, I'm sorry, dx by dui plus dy by duj plus dz by duk. One vector. Cross product with dx by dvi plus dy by dvj plus dz by dvk. Whatever cross product comes, dot with dx by dwi plus dy by dwj plus dz by dwk. If you compute this, it is same as you calculate determinant of a matrix, where top row you can keep as dx by dx by du, another is dy by du, another is dz by du. Next row dy by du, dy dx by dv, dy by dv, dz by dv, dx by dw, dy by dw, dz by dw. Or you can make transpose, because at the end we are calculating the absolute value. So top row will be dx by, for simple computation, dx by du, dx by dv, dz by dx by dw, dy by du, dy by dv, dy by dw, dz by du, dz by dv, dz by dw. Calculate the determinant. Now I have a integrand at x plus z by 3. Now consider, and limit is y, x is, z is 0 to 3, y is 0 to 4, x is y by 2 to y by 2 plus 1. How I can take the transformation from uvw to xyz? What is the transformation function I can take? Y by 2. This is hinting y by 2. Integrand is x plus z by 3. Z by 3 is hinting. Okay. If that is the case, then and y by 2 to y by 2 plus 1. This I have to make linear. This is not linear. That is the reason for the parameterization. X equal to function g over uvw. If this is the function, uvw is parameter, this is called parameterization. You introduce relationship between x and uvw through a function where uvw is a parameter. This is called parameterization. If that is the case, then I can take v as y by 2, w as z by 3, x plus z by 3 is the integrand. Then z by 3 I can take w, y by 2 I can take as v. Then how x would be linear here? So, okay, then u can I take y, y by 2 is one component, x minus y by 2. Limit is y by 2 to y by 2 plus 1. X is y by 2 to y by 2 plus if I take u equal to x minus y by 2, then this would become 0 and this would become 1. So simple, right? So z is z by 3 equal to w. So 0 to 1 is w now. Y by 2 equal to v. So 0 to 2 is v now. 0 to 1 is w. 0 to 2 is v. And u is 0 to 1. So simple, right? All are numeric now. And integrand x equal to, so u equal to x minus y by 2. And y by 2 is v, then x equal to u plus v. So x plus z by 3 was there. Now it is u plus v. Z by 3 is w. U plus v plus w. How simple it is. And dx, dy, dz is converted into du, dv, dw. So simple, right? Now only thing Jacobian, after all, it cannot be that simple, right? One conversion factor will come, that is Jacobian. So Jacobian, someone has to calculate x equal to u plus v. So front row in determinant is 1, 1, 0. V equal to y by 2. So y equal to 2v. Then it is 0, 2, 0. Then z by 3 equal to w. Z equal to 3w. 0, 0, 3. 1, 1, 0 and and 0, 2, 0. So cross is 2 and then 0, 0, 3, 6. 6 is the Jacobian. So now it is converted into 0 to 1, 0 to 2 and u is 0 to 1 and then u plus v plus w and into 6 and then du, dv, dw. How nice it is. You completely, you conquered it. If someone tells that you have to calculate integration, 6 is constant, someone can take it outside. U plus v plus w du, dv, dw. Limit is u is 0 to 1, v is 0 to 2 and w is 0 to 1. Anyone would jump on it, right? Not need that you should be educated also. It is that simple. So if you integrate, u becomes u square by 2 plus v plus w. So u square by 2, if you leave it 0 to 1, it is 1 by 2. So 1 by 2 plus v, sorry, u square by 2 plus v is vu plus w is wu. Okay, so if you take it, then v plus w will remain like that one. It is 1 by 2. Now if you integrate with v, then 1 by 2 into v plus v square by 2 plus wv. Okay, in that sense it is 0 to 2. Then it becomes 1 v square by 2 into 1 by 2. I believe that is what the situation is. So if it is 2, 2 to 4, it becomes 1. 1 and vw, it becomes 2w. So 1 plus 2w. Now if integrate with the w, then it becomes w plus 2w square by 2, 2 to go on, then w plus w square, 0 to 1, I believe 2, 12. Something like that. If someone can try. Okay, so we have covered more or less this Jacobian 3D or 4 dimensional. We will do more example of it. We talked about volume calculation like this, right, in between. So that also we will proceed on it. So we will see it.